see. Okay, we have kept an object here. Let the refractive index of the lens be mu2, that of surrounding medium be mu1. Radii of this surface be r1. It got a real object is kept. We know the rays emitted first, the rays will undergo refraction. The ray which is incident, let me choose the red color, will undergo refraction here. So it is moving from, let's assume, rare to denser, will undergo refraction. And it finally wants to meet the optic axis somewhere here. But again, the ray will further undergo refraction and finally will converge at this particular point. So what is this? This will be some normal. This will be the normal for, and this will be the normal for this one. Okay, this will be the center of curvature C1, C2. Okay, this is the thing, that one. So the ray finally, so this incident ray will undergo refraction and finally undergo refraction will meet the optic axis at a distance I. This is the object distance U. All the distance I'll measure from the optic center, so it will be P only. As is a thin lens, what we discuss is a thin lens. So our topic will be lens makers formula. Okay, that one. And this is the V. This will be V dash. So we'll have this much of thing. Okay, let's apply the refraction at spherical surface. So first at surface 1. So this is surface 1, surface 2. At 1 we'll apply it. And anything directed towards right will be positive because the incident ray is moving in the direction. Where the refracted ray is present in the denser medium. So what is the formula? Mu2 pi dash minus mu1 po equal to mu2 minus mu1 by pc1. Again, at second surface, this will be I dash will become image, this one, for the first surface, and same I dash will become object for the second surface. So again, let's apply the refraction here, refraction of spherical surface formula. So applying that, no. Where is the refracted ray is present in the rarer medium? Mu1 pi minus where the incident ray is present here in the denser medium. This will be mu2 pi double dash equal to mu1 minus mu2 by pc2. Radius of curvature of this. So radius of center of curvature of this surface will be here. Center of curvature of this surface will be at C1. So these are normal, sir. This is a normal. I'll write it here. We'll add up these two equations. By adding up 1 and 2, we'll get mu1 by pi minus mu1 by po equal to mu2 minus mu1 by pc1 . So here I'll move this one. Now what to do is like uh, we have to replace this value. So as usual, this 1 by pi minus 1 by po equal to mu2 minus mu1 by mu1, 1 by pc1, 1 by pc2. So this will be v, this will be u, mu2 by mu1 minus 1. This will be 1 by r1. This will be 1 by r2. We know from length equation, this everything should be equal to all the things you have to substitute with sign. Okay, there's a basic lens maker formula. Fine. So there's a very fundamental, almost any lens you are constructing, you should take help of this particular thing. What all we discuss applicable for thin lens. Applicable for thin lens only. Okay, this is a basic formula what we have. Now using this, we'll go for the we'll analyze the different types of the lenses here.